Energy changes in chemical reaction. Thermodynamics can be defined as the science of the relationship between heat and other forms of energy. Thermodynamic system. This refers to the substance or mixture of substances under study in which a change occurs. Surroundings are everything in the vicinity of the thermodynamic system. Heat is defined as the energy that flows into or out of the system because of a difference in temperature between the thermodynamic system and its surroundings. Heat is denoted by the symbol Q. Q is assigned a positive quantity if it is absorbed by a system. On the other hand, it is assigned a negative number if heat is evolved by a system. Chemical reactions or physical changes are classified as exothermic or endothermic. An exothermic process is a chemical reaction or a physical change in which heat is evolved. Q is negative. An endothermic process is a chemical reaction or a physical change in which heat is absorbed. Q is positive. Enthalpy. Enthalpy is an extensive property of a substance that can be used to obtain the heat absorbed or evolved in the chemical reaction. It is denoted with the letter H. At first, the enthalpy of the system is that of the reactant, but as the reaction proceeds, the enthalpy change and finally becomes equal to that of the product. The change in enthalpy for a reaction is obtained by subtracting the enthalpy of reactant from the enthalpy of the product. The key relation is that between enthalpy change and heat of reaction. Delta H is equal to Qp. The enthalpy of reaction equals the heat of reaction at constant pressure. The enthalpy H is defined precisely as the internal energy U plus pressure P times volume. Measurement of heat of reaction. A calorimeter is a device used to measure the heat absorbed or evolved during a physical or chemical change. Types of calorimeter. It could be simple as in a coffee cup calorimeter, which consists of an insulated container. 2. It could be complex as in the case of bomb calorimeter, where specific or precise measurements are needed for research to measure temperature changes under controlled circumstances and relate these temperature changes to heat. First law of thermodynamics states that energy may be converted from one form to another, but it cannot be created or destroyed. This is essentially referred to as the law of conservation of energy. The first law of thermodynamics can be represented as change in internal energy, which is equal to heat absorbed by the system and work done by the system. When the system is gaseous, work done is given by pressure multiplied by change in volume. The second law of thermodynamics is expressed in terms of a quantity called entropy. Entropy is represented by the letter S. Is a thermodynamic quantity that is a measure of the randomness or disorder in a system. The SI unit of entropy is joules per Kelvin. A crystalline substance with a highly ordered structure usually have a low entropy, whereas a liquid has a higher entropy value due to the less ordered arrangement of molecules. In gas, there is little order and the entropy is relatively large. The second law of thermodynamics states that a spontaneous process occurs only if there is an increase in the entropy of a system and its surroundings. Change in entropy, delta S, is represented as delta H over T, where T is the absolute temperature. If heat is absorbed, delta S is positive and there is an increase in entropy. If heat is evolved, delta S is negative and there is a decrease in entropy. Free energy. The factor that determines whether a process will occur spontaneously or not is the change in free energy of a chemical system. The free energy of a chemical system is represented by the letter G and is the energy that is available for doing work. Delta G is equal to delta H minus the product of absolute temperature and delta S. For a spontaneous reaction to occur, delta G must be negative. If delta G is 0, then the chemical system is in a state of equilibrium.